Okay, so for this next video here, we're going to be talking about section 1.3, which is algebraic expression. So real quick, we're going to go over some basic definitions of things, and then we're going to go ahead and kind of bring everything together. So first, we know what a variable is. A variable represents an unknown quantity. Okay, that's what a variable does for us, all right? Now, an algebraic expression is nothing more than a mathematical statement. That's what it is. So it's a math statement, okay? But it does contain a couple things. The first thing it contains is a variable term. The second thing is a constant term. Okay, and to separate these variable and constant terms, we're going to be using some math operators. And we know them as plus or addition, subtraction, multiplication, and division, okay? Now, some algebraic expressions may look like this, which is called a binomial. All right, so the plus sign will separate our variable term, VT, and our constant term, CT. That's how I abbreviate them. All right, so the first two operators separate terms. So the plus sign and the minus sign will separate terms. So because we have two terms here, we call this a binomial. So the next example, x squared minus x minus 6. This is called a trinomial. Anything larger than three terms, like x to the fourth plus x to the third minus x to the second plus x minus 1, we just call, in general, it's a polynomial. Let me spelling counts here. So it's a polynomial. And then the easiest one, my favorite, is just one term, which is a monomial. Okay? Now, in general, a polynomial has the form all right. Now, many of us have seen this. Many of us haven't, though. So a polynomial has the form an x to the n plus an minus 1, x to the n minus 1 plus, and basically you just keep writing out these terms. So let me give you one more. We'll do an minus 2, x to the n minus 2, and you will do this all the way down till you get to a2x squared plus a1x1 plus a sub 0, which is going to be our constant term. So a0, a1, all the way up to an are real numbers. Okay? And then n is a non-negative integer, and a sub n does not equal 0. Okay? Now, this is a very complicated definition if you've never seen this before, so let me explain. Okay? First, this term on the far right side is a constant term. And we know that because a sub 0 is a real number. Okay? So we know that. But then we have a1, a2, and then an minus 2, an minus 1, and then a sub n. Well, all of those, and I'm going to try to connect them here, all of these terms are called coefficients, meaning that they are, let me write that out a little cleaner here in case you're writing this down. Okay, so they're called coefficients. And why are they called coefficients? Because they are real numbers, but they're being multiplied by a variable. So we call them coefficients. Okay, now the letter n in general, so that letter n, this letter n, this letter n, all the n's that you can see, okay, are non-negative integers. In other words, they're just positive numbers. That's it. They're positive numbers. So if we let n equal 3, this is how we use this formula here. Wherever you see the letter n, you're going to put a 3, and your goal is to make sure that as you go from left to right, the letter n, 3, will decrease from 3 to 2 to 1 to 0. Let me show you what I mean here. So the first thing I'm going to write, I'm going to follow at the top of the board here, just follow from left to right. So I write a to the 3, x to the 3, plus a to the 3 minus 1, x to the 3 minus 1, plus a to the 3 minus 2, x to the 3 minus 2, plus a to the 3 minus 3, and then x to the 3 minus 3. And watch what happens. I get a to the 3, or I'm sorry, a3 x to the 3rd, plus a second, or a2 x to the 2nd, plus a1 x to the 1, plus a to the 0. Now that 3 minus 3 is going to be 0, and x to the 0, remember from our rules of exponents, is equal to 1. So what I've just generated right here is nothing more than a general third degree polynomial. That's all I did right there. All right, so there's our big review of what a polynomial really is. Okay, and like I said, these are little things that a long time ago you might have been shown like once or twice, and you may have, I know I took it for granted a long time ago, and you might have too, and that's fine, right? We're learning this together. And the thing though is, these little things matter because, like I said, chapter 3, we're going to be talking about higher order polynomials, and you got to know how to write polynomials in general. So here's just our, like I said, our just crash course basic introduction into polynomials. So now what I want to do is I want to focus our attention on operations with polynomials. And a lot of this is really, really easy stuff. All right, so the first thing we're going to do is we're just going to add or subtract with polynomials. And really, whenever I see the words add or subtract, another way to kind of say this is simplify, okay? There is one technique that just alarms in my brain, and that technique is grouping or combining like terms. Okay? And remember, to combine like terms, you got to pass two rules. The first rule, you got to make sure you have the same variable. I wouldn't even look at them unless they were the same variable. And then the second one is the same exponent. If you can put a little check mark mentally next to those two items, you can combine those terms, okay? Or you can group them together. So let's look at a really, really simple one. So we have x to the 3rd minus 6x squared plus 2x plus 4. We're going to put this in parentheses, plus x to the 3rd plus 5x to the 2nd minus 7x. All right, directions are just to simplify. All right, once again, when I see that, I'm thinking combine like terms. So first thing I had to take care of, these parentheses. Now remember, when we see parentheses, we should be thinking distributive property. All right, so technically there's a 1 out front, and it's positive, and I need to distribute that to every single term inside both sets of parentheses. However, multiplying anything by 1 remains the same, so nothing changes here. All right, so I'm just going to rewrite everything exactly how it looks. Then I'm going to get out my highlighter here. And we're going to start combining like terms, all right? So I see an x to the third. And I see another x to the third. Now, notice that not only with that second x to the third, not only did I highlight the x to the third, but I also highlighted the sign in front because you want to keep signs. So that's going to turn out to be x to the third plus x to the third, 2x to the third. All right? Now, I'm going to look at the negative 6x squared. So I see positive 5x squared. Notice same variable, same exponent. So negative 6 plus 5 is going to be negative 1x squared. Or if you wanted to, you could just write negative x squared, and that's fine with me. Okay? Now, we're going to get another highlighter. Here we go. I see 2x to the first and negative 7x to the first. They are like terms. Oops, sorry. So we're going to go ahead and group them together. So let's see, 2 minus 7 is going to be minus 5x. And then finally, the very last term right here, I'm going to highlight it in this nice red or purple color. It's just a constant term. It's plus 4. Since I do not have any other constant terms, I just write plus 4. And notice that it's in descending degree. So we might as well talk about that. So descending degree, the degree of the polynomial, is the highest overall exponent, and I'm going to put in parentheses like the highest overall exponent in the term. So this right here is a third degree polynomial, okay? Third degree polynomial, all right? So now I'm just going to kind of speed up here a little bit. We're going to look at another example. So here's our next example here. So we have x to the third, or the quantity x to the third, minus 6x squared, plus 2x plus 4, minus x to the third, plus 5x squared, minus 7x. So basically the same exact problem as before, except I have a minus sign in between these two polynomials. Now, the first polynomial, nothing changes because there's a positive 1 out front. It's the second polynomial that I really need to be concerned with, because whenever we have that negative out front, a negative in front of parentheses, technically you can rewrite that as negative 1. And I have to go ahead and distribute this to every single term. So I get negative x to the third minus 5x squared plus 7x. And then finally, I can go ahead and group like terms. So let me get out my highlighter. X to the third minus x to the third. Well, they just cancel themselves out. So I'm just going to scratch them out. Okay. Next. Negative 6x to the second minus 5x to the second. Well, here, what I need to do is combine them. So I get negative 11x to the second. Now I have 2x and then plus 7x. So 2 plus 7 is going to be positive 9x and plus 4 at the very end. Okay? So there are like your two little examples of adding or subtracting polynomials. The biggie is the next one, which is going to be multiplying polynomials. So with multiplying polynomials, it's all about this. You got to know your basic rules of exponents. Okay, you got to know your basic rules for exponents. Let me write that word, rules, a little bit better. There we go. Okay. Now, the reason for this is we're going to be multiplying variable terms together. Remember, when the bases are the same, you either add or subtract the exponents depending upon the math operation happening. Now, there is one thing I'm going to go over here in a second that I really, really hate. In fact, your book even goes over it, and it's so misleading, all right? So the first thing I want to do is I just want to do like a really, really easy example. Here's the first example right here. 3x times x squared minus x plus 1, okay? Now, we have a monomial multiplied by a trinomial, okay? So we are definitely meeting the criteria of multiplying polynomials, all right? What we're going to do here, and you guessed it, we're going to distribute. So the only thing you really got to do is just take 3x times x squared, which is 3x to the third. Remember, the bases are the same, so you add the exponents. So we get 3x to the third minus 3x to the second, and then plus 3x at the very end. And here you go. We just multiplied the two polynomials together. Okay? Here's my thing. With the next example, x plus 1 times x plus, we'll say, 8. All right? Many of us are looking at this, and hopefully you're thinking, well, we have a binomial multiplied by another binomial. Okay? Now, whenever you have this situation, okay, you were taught a long time ago to FOIL. Okay? And personally, I hate this because it teaches you bad math. All right? And what I mean by that is this. So I'm just going to pull over our book here because I do have our book in front of me. All right, so here's our book. In fact, you know what? I'm going to do it like this. I got these cool little transitions. There we go. All right. So if you look at our book right here, all right, and let me zoom in so you can really, really see it. There we go. All right, they're telling you how to FOIL, and this is great. All right, the acronym FOIL helps us remember the product of two binomials. Okay, like I said, it's fine. It's two binomials. All right, we can highlight that if we wanted to. But here's the issue. This technique, FOIL, only works when you're multiplying two binomials together. It only works when you're multiplying binomials. Then, right here, they have this beautiful sentence. I'm going to highlight it in pink that says, when we multiply trinomials or other polynomials with more terms, we use the distributive property. Well, my argument is this. Why don't you just use the distributive property from the start? Why do we have to call it some fancy name? Because what ends up happening is we try to fit this FOIL method into other problems, and it just doesn't work. So why teach the exception when what we really should be teaching is the rule? And that's what I'm all about. So let me show you how I approach this problem right here. We have the quantity x plus 1 times the quantity x plus 8. I will underline this x, and I'm just going to distribute it. Now, I know you're probably thinking, well, Professor, you are doing FOIL. And I'm not going to argue with you. But if I never told you that was FOIL, then this is the way you would approach it. So you would get x times x, which is x squared, and then, excuse me, x times 8, which is 8x. Now, I erase my little distribution lines, and I'm going to underline the number 1. And I'm going to go ahead and distribute the number 1. But I'm going to be really clever on how I write this. Watch how I write this. Please just watch the screen. 1 times x is positive 1x, and I write it directly underneath. And then 1 times 8 is going to be plus 8, and I write it directly underneath. Because if you look at the way I have this set up, not only is it in descending order of degree, but it's also already combining like terms the way I have it set up. So I come straight down. X squared plus 0, x squared. 8x plus 1x, 9x. 0 plus 8 is 8. And there is our answer right there. Now, I hope you're sitting there going, either A, that's really cool, or B, it's really, you didn't really have to do all that. Well, let me show you a much more complicated problem where this really helps, all right? And then I'm going to show you what your book has. So I'm literally going to do example 3 out of your text, all right? And I'm going to show you the difference. And hopefully you can buy into my method just a little bit, but if you don't worry about it, because I will never force you to do a problem like my specific way. The only thing I will look at is if you send me some of your work, okay, and you want me to look over it, I will make sure that your math is correct. All right? I will never force you to do it my way. I'm not that professor that goes, well, you got to do it my way or it's no way. That's not the case. All right? We all learn differently. We all think differently, and I'm going to take advantage of that. All I want to check, I just want to make sure your math is good. All right, so here we go. Here's the product, and we're going to multiply 2x plus 3 times the quantity x squared minus 5x plus 4, okay? Now, I'm going to do this problem using my way, which is called vertical addition. Now, this isn't my name. This is the actual name of the technique that I'm showing you, okay? So here we go. Underline to 2x, we're going to distribute. Now, you don't have to draw these lines if you don't want to, but I'm doing it because we're learning this. So I get 2x times x squared is going to be 2x to the third minus 2x times negative 5x is negative 10x to the second. And then 2x times 4 is going to be plus 8x. All right, there's my first distribution. Now I just erase everything, underline to 3, and I'm going to distribute again, except this time I'm going to group as I go. 3 times x squared is positive 3x squared. 3 times negative 5x is going to be negative 15x. And then 3 times 4 is going to be plus 12. So now I can come straight down and add together. So that's going to give me 2x to the third minus 7x squared minus 7x plus 12. Okay? And here is our solution. Nice and neat, organized. Didn't have to do anything too crazy. Let me show you what the book goes over. Now, here is their, wow. I guess I can zoom in a little bit. So notice here on the left-hand side, you get 2x plus 3 times the quantity x squared minus 5x plus 4, just like me. I'm going to scroll all the way over. First, they separated and they said, okay, we're going to take the 2x, multiply it times x squared minus 5x plus 4. That's the distributive property. And then we're going to separate the 3 plus x squared minus 5x plus 4. Great. Then they distribute the 2x to every single term. Then they distribute the 3 to every single term. Then they're using the laws of exponents to simplify everything. And then they combine like terms at the very end. So there are 4 steps to this problem versus if you just think about this the proper way, which is the distributive property, and then align as you go using vertical addition, you can save yourself not only time, but you can actually see how things work out, and you can see that you're actually combining terms as you go. All right? So I really, really hope you like this method, all right? But like I said, it's completely up to you, all right? Personally, I really, really like the vertical addition method, okay? Now, in your book, they do have some special product formulas, which I'm going to let you go ahead and study them, all right? So here we go. This is what they look like here. So it says if A, if A and B are any real numbers or algebraic expressions, then the first one, A plus B times A minus B, is A squared minus B squared. And we call that the sum and difference of same terms. Then you have the quantity A plus B squared, which is A squared plus 2AB plus B squared. So basically, all this is really doing here is just giving you shortcuts on how to multiply these terms very quickly. I'm not a big fan of shortcuts, only because you lose the richness of the lesson or the technique that you were supposed to learn to begin with. So just be careful when you use shortcuts, okay? So to end this end this lesson here, we're going to do the exact opposite of what we just learned, okay? So let me think about this. How do I want to you know what? I'm going to introduce it like this. So we've been in this situation before. where the directions were simplify. Okay? And hopefully you would write, well, this would just be A times B plus A times C. And hopefully we recognize that this is nothing more than that distributive property that we learned a long time ago. Okay? So I want us to look at something here. Notice that we are going from left to right in this example. And to do that, we multiplied. Okay? Well, if I went the exact opposite direction, so if I went from right to left, that is called factor or factoring or factored. Okay? And to go from right to left, what we need to do is look at both terms. And then we need to ask ourselves, okay, well, what's common? Well, if you notice, the letter A is common in both terms. Okay? So, if you go from right to left, you can factor that out. Now, if you think about it, going from left to right was multiplying. And what's the opposite of left to right? Well, the opposite of left to right is right to left. And what's the opposite of multiply? Oh, you guessed it. It's divide. So what you really did here is you said we're going to factor A plus B times A times C. Okay? And once you established that the letter A is that thing called a greatest common factor. Once you establish that, okay, what you really told me is this. Now, I want you to watch the screen. What you really said was, What you really said was, Professor, the letter A is my greatest common factor, and I'm going to take that letter A, and I'm going to divide every single term by the letter A and simplify. Now, if you notice, you have an A in a numerator and an A in a denominator, so they reduce. You're left over with the letter B. Then you have a plus sign. Then you have a letter A in a numerator and a letter A in a denominator, and you're left over with the letter C. And that is how we got A times the quantity B plus C. If we approach this technique or these problems the same exact way, then I can give you something a lot more complicated like 3x to the fourth minus 12x to the third plus 6x, okay? And then you can go ahead and tell me, well, number one, we're going to factor this, which means our first thing that we always want to do is check for a greatest common factor. Check for that GCF. So if you look at this, and this is the way I like to approach it, all right? Anytime I factor a GCF, the first thing is I look for a GCF for the numbers, and then second, I look for the GCF for variables. Ironically, the GCF for the variables is a lot easier than the GCF for numbers. So let's go ahead, let's do the numbers first. So I see a 3, I see a 12, and I see a 6. Okay? So hopefully we're to the stage now where you can look at the numbers and say, okay, the GCF for the numbers will be a 3. So I'm going to write a 3 and just kind of put parentheses underneath. Notice the space I left there, okay? Then we look for the variables. Now the variables, the GCF, well, it's always going to be the smallest exponent. Whatever that smallest exponent is, that's going to tell you how many you can factor out of each term. So going from left to right, we have x to the fourth, x to the third, and then x to the first. So my GCF overall is just going to be 3x to the first, or if you just want to write it as 3x, that's fine by me. But here's what you've told me. By telling me the GCF is 3x, to simplify this, you are going to be dividing every single term by this 3x. And you're going to tell me what's left over. So what's left over? The 3's reduce. X to the 4th divided by x to the 1st is going to be x to the 3rd. Now you have a minus sign, so copy it down. 12 divided by 3 is 4. Then x to the 3rd divided by x to the 1st is x to the 2nd. And then finally, you have a plus sign, so write a plus sign. 6 divided by 3 is 2. X over x is just going to be x to the 0 or number 1. But if you think about it, 2 times 1 is just 2. So here is our factored form. All right. So that's kind of how we approach factoring out a GCF. All right. Now, here's the hard part. There are a lot of different factoring techniques. Okay. I have a flowchart that I'm going to upload that you can use. Because if there's one thing you're going to learn about me, I don't like shortcuts, which I already said. And then I don't like to guess. Okay? Now, within your book, if we factor a trinomial here, that's a trinomial, x squared plus bx plus c. Notice here they're saying by trial and error. I don't like that. I don't like to guess things. Now, I'm going to show us, and if you want to walk through this, okay, with me, by all means, walk through it with me, okay? I don't like guessing. I like more of a systematic approach. Unfortunately, I cannot go over every single different type of factoring situation that you're going to run into. But what I can do is upload previous lectures that I have that kind of detail this. All right, so I'm going to do that for us. All right, and it's going to be in a special folder called factoring. All right, because factoring is tough. So what I want to do now is I want to go back to our notes and I want to show you what I'm talking about. Okay, so here's an example here. And we're going to factor x squared minus x minus 6. Okay, so this is a trinomial. Now, I want us to look at this factoring flowchart real fast. Okay, so here's our factoring flowchart. So I'm going to zoom in for us for a little bit, just so we can see what's happening here. All right, and I'm going to try my hardest to highlight things. So first thing you always want to look for, factor GCF. That's the first thing. Second thing you always want to do is you want to identify the polynomial type. So notice you have basically 3 branches. You can go up here to the binomials. You can come down to the middle, which say trinomials, or you can go all the way down to the bottom, which is a polynomial with 4 terms. Anything larger than 4 terms is going to be found in chapter 3, which is higher order polynomials. So let's go back to our problem real quick, just so we can look at it again. So we just want to factor x squared minus x minus 6. So this is a trinomial. And if we look at from left to right, we do not have a GCF. So going back to the flowchart, factor out a GCF, we can't. What type of polynomial? It's a trinomial. And more importantly, it's a trinomial with a equal to 1. Now, if you're thinking about, well, what does that mean, a equal to 1? Well, if you go back to our problem, the general form of a trinomial is ax squared plus bx plus c. And the a is going to be the coefficient on the x squared term. So in this case, it's a 1. And that is great for us. So if we go back to our flowchart for one more time, we can just go from left to right and just highlight this and say, okay, well, this is what we need to do. First, we need to find 2 numbers that multiply to give us our factor 1 and factor 2 that will multiply to give us c and then add to give us b. Okay? And then they give you like a nice little example here. So here's the way that I approach this problem. All right? First thing we're going to do is we're going to write the multiplication of 2 binomials. Because when we multiply 2 binomials together, the answer is a trinomial. So I can write that off to the right here. So binomial times a binomial is going to equal a trinomial. Now, this isn't always the case. We do have special cases where we have a binomial times a binomial and it equals a binomial, but we'll get there. Now, this is what I always do. Step 1, I write down the x's, and I always copy down the first sign. Now, many of you were told find two numbers and then do the sign second. I do it the exact opposite way, and you're going to see why. So I always copy down the first sign. Now, I know this number here, and whatever this number happens to be, it's going to be either a positive or a negative number. Now, those two numbers have to multiply to give me another negative number. So if the first number is negative, then the second number has to be positive, because a negative times a positive is another negative. All right, now, the reason why I do the signs first is because of my next step. I'm going to find two numbers that multiply to give me 6. And here's the best part. Since you already did the signs, you know one of the numbers is negative and one of them is positive. And the only way that you can get, let me highlight this here for us in blue. The only way that we can get this -1 right there is if we have +2, -3, which is -1. So this is going to be x minus 3 times the quantity x plus 2. And there's your answer. All right. That is the beautiful part about this technique, is if you do the signs first, then finding the pair to combine to give you that middle term is much easier. Okay. So let's go ahead and let's try another one here. Okay. We're going to try one more, and I'm going to show you how this technique works again. Okay, so here's our next problem here. We're going to factor x squared minus 7x minus 60. And this problem is exactly like the previous. No GCF. The polynomial type is a trinomial. And a equals 1. So we're going to go ahead and we're going to do two binomials with an x and an x in front. Now remember, I always copy down the first sign. So that's going to be a negative. Now, in green, let me highlight it one more time just so you can see it. This number multiplied by this number has to be a negative. Got to be a negative. So if the first number is positive, the second number has to be, if the first number is negative, the second number has to be positive. And that'll give you a negative value. Now, here's where I think my method really comes together. When we think about the factors of 60, 1 in 60, 2 in 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 8 doesn't work, 9 doesn't work, and then you're back to 10 times 6, so you just repeat it yourself. By doing it my way, which is okay, if you don't want to do it my way, that's fine, I'm not going to argue with you, but we already know one of these numbers is negative, and the other one is going to be positive. And the only way that you can get -7 is with +5 minus 12 equals -7. See, you can actually see that it's these two numbers right here. There's no more guessing. There's no more, well, I'm going to put these two numbers here, and then I got to check myself, and if it doesn't work, I got to switch the signs. No, that's gone. All right? So this is going to be x minus 5, and then x plus 12. Okay? Now, the next one I'm going to do is one of the more difficult ones. Sorry, hit the wrong button there. It's going to be one of the more difficult ones where it really helps if we have a technique. So let me show you what this problem is. So we're going to factor 6x squared plus 7x minus 5. Okay? Now, let's go right through. We're going to look at our flowchart again. Okay? And we're just going to go right from left to right on our flowchart. So, hopefully you got the problem written down in front of you. Factor out a GCF, we can't. Polynomial type, well, this is a trinomial. Now, in this situation, the number in front of that x squared is a 6. So, in this situation, it's not a 1. So, they tell us to go ahead, use the AC method for factoring. and then create a 4-termed polynomial, and then finally factor by grouping. So I'm going to show you how to do this. It is so simple, and it completely gets rid of the guess and check method. Now, here's what ends up happening with a problem like this. When you start factoring, you could factor it like this: 3x plus 1, and then x minus 5, okay? I'm sorry, 2x minus 5, because remember, we need to get 6x squared. But the answer could be 2x plus 1 times 3x minus 5, okay? Or you can have a combination of these. So you don't want to guess. Guessing is bad. Guessing wastes time. Guessing does not really show you that you know what you're doing, because you were literally guessing. So we're going to use the AC method. So if you've never seen this before, I want you to really take your time. I want you to watch. I want you to write things down. Rewind the video if you have to, and just go over it and over it. So here's how we do the AC method. Step 1. I'm just writing out the polynomial off to the right-hand side. We're going to take A times C. So in this case, it's going to be 6 times 5, which is 30. Okay? Now, I'm also going to write this right here, and I should have did this first. Directly underneath, I call this get an idea. And what I mean by that is, let's pretend this 6 isn't even there. If this was our problem right here, we would write x and an x. We'd copy the first sign down, and this second sign has to be a negative. So that's what I mean by getting an idea. In other words, I know my answer at the end of the day is going to look like x plus something and then x minus something. It's just, what are the numbers inside of this parentheses? So step 1, we're going to take 6 times 5, which is 30. Notice I don't care about the signs. And I don't care about the signs because I already got an idea. Step 2, we're going to write out the factors of 30. So that's going to be 1 times 30, 2 times 15, 3 times 10, 5 times 6. Those are all the factors of 30. Now, let me get out a different color, because I know when I take these two numbers, okay, and I add them together, I need to get positive 7 in the middle. And I know one of the numbers is positive, one of those numbers is negative, because I got an idea at the very start. So what combination gives me that? Negative 3 plus 10 gives me positive 7. So I'm going to put a box around all that. Now, here's what's happening here. Step 1. Sorry, I'm messing with my window there. Here we go. Step 1, use the AC method. That's what we just did. Now what we're going to do is we're going to create a 4-termed polynomial. And let me show you how I do that. So we go back to here. So we know negative 3 plus 10 is positive 7. That's a really thick marker. Let's get this skinnier one. There we go. So step 3, create the 4-term polynomial. So here's what I do. I'm going to write 6x squared. And instead of writing plus 7x, here's what I'm going to write. Negative 3x plus 10x and then minus 5. In other words, I take from step 2 the negative 3 into 10, and I write negative 3x plus 10x, because I know that equals 7x at the end of the day. So I just created a 4-term polynomial. And now I will factor by grouping. Okay? So let me just rewrite this real quick, and I'll show you how to factor by grouping. So factor by grouping, we group the first 2 terms together and the second 2 terms together. Now, we do not group that middle sign. That middle sign always just drops down. Next, we will look for a GCF in the first grouping. So the GCF for the first grouping is 3x. And that gives me 2x minus 1 left over when I factor out my first GCF. My second GCF in the second grouping is going to be a 5. Now, the beautiful part about factor by grouping when you have 4 terms, it has a built-in check system. In other words, you know you are doing this problem correctly because look at what's left over inside these groupings. It is the same exact expression, 2x minus 1. And because they're the same exact expression, we can take these and factor it. Okay? So watch what I do here. I'm going to rewrite this so that I have 2x minus 1 out front. And then what's really happening here is this. Remember, let me just erase these. The 2x minus 1 is a greatest common factor. It's a GCF. So if you are telling me that both terms have the quantity 2x minus 1 in common, and you're factoring it out, then you are dividing both of them by 2x minus 1. 2x minus 1 over 2x minus 1, they reduce, they basically, cancel each other out. So you're going to be left over with 3x plus 5. And just to keep it nice and neat, I will write it in the same color of a marker. 2x minus 1 times the quantity 3x plus 5. And that is your factored form of 6x squared plus 7x minus 5. Now, you may have your own method, the guess and check method, and that's fine. You want to keep doing that, by all means. But I can tell you this. This AC method is by far the most efficient method, and you will never, ever guess. And it's because you have a very systematic approach on how you do this. So I just want to go over it one more time. First, get an idea. The idea, really, you don't even have to write X's here. The idea is all about understanding what are the signs in between. Like, that's what we really want to know. What are those signs? Always copy down the first sign, figure out the second one. Step 1, take A times C, 6 times 5 equals 30. Step 2, write out those factors. Within step 2, find the 2 factors that combine to give you that middle term. Okay, find the 2 factors that give you the middle term. Use them to create a 4-term polynomial. Okay? Then, factor by grouping. You will group the first set of terms together, the second set of terms together. Never group the middle sign, though. Just write it down. And then finally, and I'm going to just redo this real quick, and I'm going to make it look nice and pretty. All right, I just want to do this real quick again. When you factor by grouping, there is a built-in check system, and it's going to be once you find your GCFs for each group. These two have to match. If they don't, you've done something wrong. Go back, make sure your signs all match and all that stuff, okay? But once you figure this out, once you go, oh, look at this. The quantity inside of the parentheses are the same. Factor it out, and then you can literally rewrite what's ever left over. In this case, it's 3x plus 5. Okay? So the last example I want to do is just a really easy one. All right? And this is great if you come across this example. And I gotta stress this enough, okay? There are more factoring things out there that we just don't have time to go over. You should have seen them in MAT108 if you took intermediate algebra, and MAT90 if you took algebra fundamentals. If you run into a situation, all you got to do is ask. I am always available to answer questions. All right, so here's this example right here. So let's go ahead. Let's look at our factoring flow chart. So we're going to factor 4x squared minus 25. So factoring flow chart. First, factor out a GCF. Well, there isn't one. Second, what's the polynomial type? Well, in this case, you only have two terms. So this is going to be a binomial. But now you need to ask yourself, okay, do I have perfect squares or do I have perfect cubes? The answer to that question is going to be within the variable itself. So if we look at the variable, this is x to the second power. Well, that's a square. So really what we need to ask ourselves is 4 a perfect square? And is 25 a perfect square? Okay, and the answer to that question is yes. We know 2 squared equals 4 and 5 squared equals 25. So we meet all the criteria. So if we go back to our factoring flow chart, yes, we have perfect squares. Now you need to ask yourself, what is the sign in between? Is it a difference, meaning minus, or is it a sum? If it's a difference, you have what we call the difference of squares. Okay? And it can be factored using this formula. Let me highlight the formula for us real quick. It's this little formula right there. A squared minus b squared equals a minus b times a plus b. If the sign in between the two terms is a sum, it does not factor. Okay? Now for us, if we go back to our problem, we definitely have a minus sign in between, so we have what we call difference of squares. So what we're going to do is we're going to use that formula. So let me write it out here. So it says a squared minus b squared equals a minus b quantity times the quantity a plus b. So this is nothing more than just the quantity of 2x to the second power minus 5x to the second. In other words, this 2x is like the letter A. The 5 is the letter B within your formula. So this factors down into 2x minus 5 times 2x plus 5. And that's it. So there was no really figuring things out. You just had to be able to recognize that you have difference of squares. And I will be honest with you. You will see difference of squares a lot in my class because it's something that, number one, it's really easy to factor, but number two, it really demonstrates that you understand what factoring really is, and it makes it real simple, and it's time saving because I can only give you so many problems on a homework or a test or something like that. So please make sure you are reviewing all your factoring techniques because we're going to be using them a lot. That's going to be it for this video. It's a long one. I'm sorry, but I just wanted to make sure I was a little bit more thorough than the previous. So enjoy, and I'll see you in the next video. Bye.